Hey Daniel, do you think we want to do some brief introductions? There's a lot of people on the call, but
I think it's probably worth introducing the groups that are here, just so everybody knows who's playing what. But I don't know if we need to go through and do individual introductions.
okay, I think that's a good idea. Maybe we can get started on that while we wait for a few more people to join. So I can maybe introduce the group from Sonomatic. So I'm Esteban Cesan. I'm the U.S. Regional Manager and the Project Manager for this project. I'm based here in Houston. From our side, we got John Lilly, who's our General Manager for the company on. Gordon Davidson, he's our project manager slash technical authority from the UK that's been helping us manage the project. I got Agatha here, who's works in operations with me here out of Houston. Gideon, who's level 3, that's been doing all the procedures, done a lot of the qualification work in Houston before we had to transfer the project over to the UK because of COVID. And James Butterworth, who's our equipment guy, who's been working furiously to pull this thing together, trying to get all the parts built and everything. And Russ Price, who is one of the techs that will be on the project, hopefully, and he's going to be doing a lot of the video demonstration from our side. So that's the Sonomatic team. Maybe I'll hand it over to David if you want to introduce the TSC guys that you got here.
Yeah, hi there. So we're about to go live on the video demo. Can you hear me okay?
Yes.
Yeah. Okay, good. So we've got, I'll turn the camera on. And Elliot, if you go over to the ACFM gear. So we've got Elliot by the ACFM gear. He's just going to point out to you a couple of things at the moment. He's going to point out the ACFM underwater pod, which is what the divers take subsea and deliver to the worksite area. The probe cable from the subsea pod is 10 or 20 meters. We've got 10-meter cables connected at the moment. Okay, so
I think David, sorry to interrupt, but we'll get to the specifics of the equipment in a little bit. We're just doing introductions. Maybe you missed.
Okay.
Maybe you missed a little bit. Yeah, we're just doing intros at the moment. Yeah.
So Matt, you're going to join us. Right. Matt is helping us with the scanning. We need sort of effectively a diver for some of the scans. So Elliot will be running the ACFM kit. So Matt should be in front of you now. Hold your hand up, Matt. Yeah, okay, so there's Matt. And I'll just come around. Hi, everybody. Dave Paramore here. So I'm running the ACFM TSC.
Perfect. All right, Daniel, you want to introduce the 2H team?
Yeah, so Daniel Reagan, I'm here kind of helping manage, deliver all this stuff, getting through all the wet trials and all the qualification work. And then I believe also Chris Patton's online. He's the overall project manager for the iTube life extension scope of work.
Okay, so let's go through the pod again.
Okay, Technique, maybe if you guys want to make some introductions.
Mike Fury online right now, project engineer. I'll be going offshore with this scope. Dana Cooper should also be joining shortly. She's been looking after the procedure and equipment readiness for the scope.
Okay. And Suncor?
Hi, so this is Adam Downton. I'm the project lead. So I think just looking here, who I got on the line, I got Mitch Groves. He's part of the execution team for the iTube scope, so he's interfacing with Technique. I have Michael Kierkegaard. He's part of the iTube project team, and also Jeff Manning is on the line there from the iTube project team.
Thank
There's
you for that.
a couple others I'll add to that as well, Adam. We've got David Whalen and Leslie Scaplin. Apologies, Leslie. they're both part of the subsea project engineering team. So likely going offshore at one point or another. And we've got our dive safety specialists on the line as well. So that's Dennis Barrington, Sean McPhail, and Paul Sullivan.
And also, guys, we've got Dwayne Hawkins on the line as well, part of the iTube project team.
Okay, fantastic. All right. Well, I think I just want to do a brief overview of the intention and what we're trying to achieve today, and maybe how we want to go about it. There's a lot of people on the call, so one of the things that we want to try and keep control of is I'm sure there's going to be a lot of questions as we go along. So what I think we want to try and do is there is a chat for the within Teams, and if anyone has any questions they'd like to ask, if they can type them into the chat, and then at the end of every little mini session that we've organized, we'll leave a bit of time there to go through the questions and make sure that we address any questions that come up. This is the schedule. Can you guys see my screen with the schedule at the moment?
No.
No?
I can see it. You may have to click on it.
Yeah,
It's there? Okay.
Yeah,
So this is the schedule.
I was gonna say, just click on it, guys, and it comes up.
Right. So this is the provisional schedule that we put out. So there's going to be an initial equipment overview where we're going to talk through the Nautilus kit, go through how the rings work, how the rack arm works, the different probe assemblies, how we plan to swap out, and cable management. It's really geared towards giving the dive team and the dive people that will be involved a good overview of how the tool works, so they can understand what they need to do when it comes to the project. So we're going to go over, we've scheduled an hour for that session to go over all the equipment and hash out any issues. Then we're going to spend about half an hour demonstrating how we attach the tool to the flange and all the little things that, all the little adjustments that need to be made to make sure we get a proper alignment and make sure the ring's set properly so we can pull some good scans. Then I'm going to hand it over to David, and he is going to go over the ACFM. We will pull some ACFM scans, show you how that works. We've collected a few videos yesterday because when the probe is in the water, it's going to be hard for anybody to really see anything. So we've pulled some scans in the dry air that we will show you the videos of, so you can get a good feel for what we're doing. David, during this point, is going to do a little demonstrations on the MSF tool as well that he's been doing yesterday in the tank. Then we are going to switch back to the Toft. We are going to demonstrate how we can swap over to the Toft, and we'll pull some Toft scans and have any discussions around the Toft. So that is the plan for the day. I thought I would start, one of the questions that there's been a lot around is how we plan to deploy the unit and the tool. So I thought this part of it is not fully complete yet, so we don't have that to show you. It's still being built out, but I wanted to show everybody. I'll just quickly jump over to another screen here. Okay, you guys should be seeing a PowerPoint presentation now.
Yes.
Yeah.
Okay, so this is the final design of what we intend to put in the water. So what we've shown to date is this main section of the pod, which is one is our ultrasonic pod and the other is our motor control pod. And this is the cable management and probe management. We're calling it the X-frame that we plan to put in the water. So we'll have the two pods. This is the ring that will go down. This is the Nautilus tool. Over on the right here is the main drive cable that comes to the Nautilus. And then over on the left, we'll have all the different probe assemblies to carry out the individual tasks. So we need to do, for those that haven't been part of the meetings. We need to do 3 separate techniques. We need to do time of flight diffraction. We need to do phased array. There's a couple different probes that we'll be sending down for phased array of various sizes. So we have potentially up to, and then, sorry, we also need to do ACFM. So 3 separate techniques. The phased array will have a couple probes. So the intention that we are trying to do is to put everything down in the water in one deployment and allow the divers to just swap between the different techniques without having to recover the tool back to the surface. So this is the idea. This is how we plan to sling it. So there's going to be a sling with 4-point harness, and that'll be deployed horizontally. So that's kind of my introduction. With that, I will hand it over to Russ. I did want to let everybody know as well that we are recording this and we'll be posting this entire session up to YouTube, and there's also a service Microsoft calls Streams as well. So all this will be available. We're also going to create some mini videos for each individual segment that we'll also post. So all this information will be available to everybody after the call, probably early next week. So with that, I will stop sharing and I'll hand it over to Russ. Hopefully you guys are ready, and if you guys can start sharing your video and take it away, Russ.
Okay, so sorry guys, can you hear me?
Yeah.
Yes.
Okay, we haven't got Russ at the moment, so they're just dropping the main eye tube into the tank. So there's a bit of hands-on there. So we're just going to take you through the ACFM equipment for 5 or 10 minutes before we swap over to the Nautilus and the eye tube system. So I can just see that we've got the ACFM area sort of on screen. Tell me if the video is not acceptable. Obviously, it's the start of the video. So, Elliot, can you show us the subsea pod? So this is the pod, the TSC U41 unit. This is deployed by divers, so over the side, and then with the washing lines deployed to the site. You can see that we've got a green umbilical cable. That umbilical cable is currently the 20-meter set. So we use that for deck testing and for going from the deployment area from over the side to the control cabin. But what's just been brought into view, I think it's in view, is the umbilical. So on this drum, we have 150 meters of umbilical cable. That umbilical will connect to the U41 bottle in exactly the same way as the deck test cable is connected now. And you can see that the cable has got wheels on it, so you can sort of secure the ends of the cable. There's a bit of a wrap around the end of it for that to be secured, and then you can wheel the cable around the deck and so on. So we don't need the 150 meter cable for now. It just gets in the way at the moment, so we'll take that out of shot.
Hey Dave, one question. Sorry, Esteban, I can't actually do the chat. It says that only team members can do the chat. So sorry, I'm just going to jump in here for a second. But the I guess the module that goes down, is that going to be integrated into the Sonomatic frame?
It can be. So we haven't got the detail of that together as far as I know. We were expecting the U41 to be deployed separately, just on its own lifting point. So it has a lifting eye. Elliot, can you show us the lifting eye? So it has a lifting eye on the top, and we use that for deployment over the side.
Okay, gotcha.
Okay, can you see that okay?
Maybe a little to the left. There you go.
There we go. Okay, so that's the lifting point. And normally we don't integrate so closely with sort of other tooling like the Sonomatic tool. So it's just a case of the cable management and whether that's easier to deploy it on the same frame. And that to a certain extent is up to Sonomatic.
Okay. Thank you.
Okay. So we're going to go on now to the topside unit. Elliot's going to show you the topside unit for the ACFM. Okay, so this is an interface box. It takes 110 volts AC mains in. It gives us a mains out to power the laptop from. That mains out is RCD protected as a result. And towards the right of the instrument box is the diver safety function. So there's a trip and a reset and a test button over there. And at the top of the right-hand side, you can see the connection to the umbilical, right? So it's done as a sort of like an extension cable. So our 150-meter umbilical just joins on the end of that green cable, which is 20 meters, to give you 170 meters of total cable length. Okay, so data acquisition is done using a ruggedized PC. We've got a ruggedized PC in view, I think. That's what the ACFM operator needs to have good access to in the dive cabin, and that's where he interprets all results. And then moving over to the probes, this is the probe that we're going to be using on the Nautilus setup. So that's the first ACFM job of the day. So that's connected to the probe connection on the ACFM pod. You see the connection point at the top of the probe. That's currently with a right-angled connector. So our cables are right-angled one end and straight the other end. So we have a bit of a choice as to which way the cable comes out. And we, depending on the application, might swap from right-angled to straight. So for instance, when we're inspecting the radius, the flange, sorry, the radius of the forging, we'll probably be using a straight cable entry. But anyway, that's the probe holder for the Nautilus system. And if we move over to the MSF.
Hey Dave, on the Nautilus piece there, so that's the part that Sonomatic has fabricated, and that's the integration piece. So that integration all went well. There's no issues there.
No, I can't say that 100%. So okay. This deployment frame, you can see it's got a constant force spring, which is pretty good, and it's mounted to the probe. But because of the bend in the eye tube, we actually need a bit of a gimbal on the probe itself. So the probe is going to be gimbaled in the center of the probe. So Sonomatic are on to adding the gimbal for that unit. So, but it doesn't stop us doing the demo. It just makes the inspection of the lower toe, upper toe in real life, but the lower toe and the heat affected zone beyond the weld, we get a bit of lift off as we go around. So that's going to be dealt with sort of during the day, but there's a plan to correct that for us. Okay, so moving on to the MSF. This is the MSF. Can we, Matt, can you get the other one? So we've got two MSF frames. One set up for doing the scanning. We've added the encoder that we said we would to the top of the unit there, and you can see the wheels and the positioning of the probe holder. So we'll be using this to do any scans later on in the day that you need us to do. Basically, we've done some testing on this, and we can show you this as part of the video. But we've tested several things. One is the height of the magnets. So you can see those little white patches with red internals. They're the magnets. We've tested the function of those, and they're set with 10 millimeter liftoff, so they clear the aqua signs. And we're finding that the pull force of those magnets are absolutely fine for us. We've tested the buoyancy in the buoyancy tank, and it seems that the buoyancy is about right as it is. So we'll be able to show you that later. There's pressure-capable foam sandwiched between two plastic plates that forms the backbone of the structure. And can you just point out the encoder, Elliot? Yep. Can we still see that? Yeah. So the encoder sort of is sprung, and it springs against the I-tube mount and records position as we go around the I-tube. And then we've got the slide for the probe holder itself. Which is adjusted and can be locked, and the angle of the probe can be changed so that it suits the radius of the forging and also the dissimilar metal weld position. Okay, so there's tabs on the diameter that set the different I-tube dimensions. So they can be slid quite easily using the cam locks to reposition those. It's a bit awkward if it's being done just single-handed. But basically, you set the diameter for the diameter of I-tube that you're inspecting, and it runs that around the dissimilar metal weld and the buoy surface very, very well, we find. So, have I left anything out? The wooden clamp that you see, I'm just making sure we can actually see the table around the pipe. Thank you, Elliot. So we built a simple wooden frame that clamps around the pipe of similar diameter to the I-tube. So we've brought this pipe along because it's small enough to fit into the tank and be handled without all the problems of handling the full-size sample. But we had this on the I-tube sample yesterday, did quite a few tests, and took plenty of video to show you the performance of the scanning frame over a aquasign, over a seam weld, and we were very, very pleased with the performance. So I think we're in good shape to go forward. So that's basically it. That's the introduction to the ACFM equipment. Any questions on the equipment so far?
Dave, just to confirm the I guess the adjustable components there to size it to each of the three different I-tube sizes. There's graduations on that, correct?
Yeah, there are graduations on that, and there's also a machined recess to take a centimeter type scale. So we've drilled holes, so we've predetermined the right locations for the sizes of I-tube. So we're just going to show you that now, see if we can get a close up. So you can see the red dot there is aligned with a specific window. And so we can tell that that's the right position for one of the I-tubes. And there's a legend, which we haven't printed off yet, which gets adhesive stuck down onto this portion here.
Thanks, Dave.
Okay, no worries. The last thing, actually, I forgot to mention was we applied some pots to take air, and we machined some foam that could go in the pots. Can you show us, Elliot? Yeah. So, John, just take the camera over and show.
Yeah, okay. Air pockets here. We can also just place buoyancy direct inside. We can hold that down with either a bolt, or we can glue it in as if it's going to be permanent.
Yeah, so we've come prepared to do buoyancy adjustments as necessary, but we've sort of set it up already and we think we don't need the additional buoyancy. So in fact, we're going to sort of not have those present during the scanning. So I'll be able to explain that more fully, sort of in the right place in the schedule. But basically, we've found that the as-is buoyancy without that additional buoyancy is easily adequate to do the job really well. And we tested it in the correct orientation, i.e., as per the on-site buoy, with the scanning frame turned upside down compared with where it is now. And we found that the MSF stuck to the buoy surface with about a 50 Newton force. So it took about 50 Newtons to push or pull the manual scanning frame off the buoy surface. And the maximum spring force that pushes the probe down onto the surface is around about 20 Newtons. So we thought that this level of force was about right. And it was quite awkward to deploy the system with good vision because of the not being able to be under the buoy surface. We're having to do it from above the water surface. But it was clear that you could just remove hands, and the MSF stayed in position really well. And so this is ideal for diver use. They don't need to have close hands-on all the time of the MSF frame during use. They can just stop and it stays put in its current position, and then pick up again with the scan and continue with the scan once they've repositioned themselves and got more comfortable or in a place where they can provide a reaction force from a diver point of view. So our own assessment is that we've got it about right. It suits. So that's about it from me. If there's no further questions, I'll see if we can hand over to the Nautilus team to take you through their kit. Okay, I'll just mute for a second whilst we get the
Need to do the cable tie.
Okay, Esteban, I think the guys are suggesting that you give a bit of a run through of the system, and the guys will be able to point out what you're looking for. Let's just adjust the camera so that we're on the right level.
Where's this coming? Can't go away, can it?
Russ, do you want to come over and sort of take control here then?
Can I actually hear Esteban?
Yeah, you can hear Esteban, and if you can hear Esteban and deal with that,
Yes.
Give us a shout if you need a hand.
Okay, mate. Right, how do you want to work it? We've got the pipe and all rigged up in the tank. There's nothing on it. First of all, would you like the camera being closer?
Well, no, I think we're okay, Russ. If you can just show everyone the Nautilus first.
Well, we'll do it step by step. I'll show them the ring, and then me and Jamie will act as divers to attach the ring to the makeshift flange that we've got rigged up. The guys are just finishing tightening everything up. But I can stand in front of the camera, tell me when I'm visible, and I'll stand there with the ring.
Yeah, if you can talk to the ring first, that's a good first step. Yeah.
Thanks, Esteban. While we wait for that, go for it.
Yep. Okay, go ahead, Russ. Yep. Sorry, Daniel. Did you want to ask a question there, Daniel?
No, I was just going to say while we were waiting in the background that appears to represent the API flange that's sticking out of the water, but we'll get there. Just go ahead, keep moving.
Yep. Go ahead, Russ.
All right, what we've got for this demo is a 26-inch diameter ring, and for easeability of divers, when they're attaching this, they will only require 2 Allen keys. What you've basically got, I'm just going to tilt the camera so I can sit it down. Obviously, at one end, you have an opening. The other end is a hinge. And it's just 1 Allen key to loosen it off, and then it opens, and it's hinged at the other end. To attach it, which we'll show you in a minute, the divers will take this ring down, closed, opening it up when they're at the flange, wrap it round, and then immediately, first thing you do is close the lock and then retighten it back up so it doesn't move. Once that's in place, it will be slightly loose on the flange. What we have then is a number of adjustable feet. Again, with the same Allen key, 6mm, it's a simple method of adjusting the feet equidistantly. So it's like when you're putting a wheel back on a car. One diver will adjust 1 foot, the diver on the opposite side will adjust the opposite. We work it round 360 degrees until the ring is sat in position and totally tight on the flange. And basically that's the what we call the ring. We have different sizes for different flange sizes we'll encounter on the job. So basically what I'll do now, I will reseal it, and then me and Jamie will act as divers as if we're subsea, so we're putting it physically onto the flange. So I'm not sure if you'll be able to hear us when we're over there, but as long as we set the video up, it's just exactly the same as what I've just showed you. So if you want to grab another key,
Russ, it's Gordon. Do you want to show how the Nautilus would mount to the ring whilst we're nice and close? Because it won't be so clear when you're further away.
Say that again, Gordon. You can do that as well, Gordy.
Show how the Nautilus, the Nautilus will eventually get mounted onto the ring, just so it's nice and clear here. It won't be so clear when you're on the work site.
Can you guys see that? What we've got now, this will be the Nautilus scanner. And again, this will all be fixed topside and set up. Then all we do is 2 attachments here, which have bearings running through. We will loosen those off topside and send it down loose, so that once the ring is in situ, the divers will then, just bear with me, Jamie, can you just come and hold this ring, mate? Yeah. The divers just line 1 set of bearings up, and while it's on, they will then tighten this up so that the bearings run into the holder. As I said, we'll set it topside, so it should be nice and secure, but it will still free run. Once this is attached, there's a cog system here, which the diver will then just start to adjust it until the cog engages with the teeth. He will adjust that as tight as he can. Then we'll instruct him to take 1, 2 half turns out, just to relieve, give us a bit of play. And that will then be the Nautilus in situ, ready, locked. It will not move. Once it's locked in like that, the only way it can move is when we drive it with the computer. The next thing, well, I've got this. I'll just put this on. So imagine my other diver now. 4mm, yeah, all the way in, 4mm Allen key. And at the moment, we are planning on doing this as we've just done it, 2 separate functions. Depending on the situation offshore, tides, swell, this may come down already connected. we'll discuss it with each dive with the diver before we deploy. So it'll be the diver's decision. So again, now Jamie's tightened that. So if I just lift the machine, everything's together. But it will free run. So the next stage would be the diver, and he can do this on his own. We'll start to engage the cog mechanism to attach to the ring as tight as he can. 1, 2. Now that, because we've got it live and connected, that will not move. There's no way that will move. That's now controlled by the computer if we want to go clockwise or anti-clockwise. At that point, we will then, there's 4 bearings on the top. We will then present a rack arm again. It'll all be set, and it's just basically a steel bar with teeth that goes between the bearings. And if you push it, it'll go. Again, it will run freely. Then once they get it underneath, there's another knob which is on a cam. You can keep rotating this 360 degrees, it just engages and disengages. So it's just a quick, gently move it, and they'll feel it click, and then again, that is now locked in position. It will not move. Then the next stage will be whether it's the ultrasonic probes or the ACFM probe. You grab us the ACFM one for now, so that's what we're doing first. At this end, we've just got a lever that goes on. The diver just pushes the probe on as far as it will go, and then tightens that up all the way. And it's sprung assembly to take up any differential in the gap. And basically, that is the setup. Then, obviously, we'll do the inspections, and to then disassemble, it's just exactly the opposite. We disconnect the probe, that would get put back away. Then we would grab the next inspection head that we're going to use. It's not physically going to be this one, but it'll be the same idea. Just comes along, pushes on, and tightens up. As I said, this isn't the head that I'll be using. It'll be the same that this adjusts. And again, we do the next inspection. So say we just on the time of flight. It's just a matter of then remove that, store it. Then we get the next probe, which will probably be a phased array, and it's just the same process. Bring it on, tighten it up, do the inspection, de-rig it, the next transducer, etc. Once the inspection is complete, it's just a reverse to get this back into the basket for recovery to surface. So it'll be disengage the rack arm, which comes off. We would then disengage the scanner from the ring. Again, 4mm Allen key, take 3 turns on each of the screws. Maybe one more. So the Nautilus disengages from the ring, and again gets taken away back to the basket and secured in the basket. And then to disengage the ring, there's 2 ways we can do it. We can either slacken off all the feet so it becomes loose, then undo the hinge. But the quickest and easiest way is just to simply open the ring up, remove it off the flange, Then while they're away from the flange, reclose it, resecure it. And then physically, then back all the feet back off into the house, and then that can go to the basket. So that's basically the whole procedure of what we plan on doing. You got anything else to add, Esteban?
That's excellent, Russ. Very good overview. Thank you. Daniel, trying to see if there's any setting that I can do to fix the chat, but I don't know why that's not allowing people to put things. So I think maybe we just pause now and ask if there's any questions from anybody they'd like to ask of anything we've shown to date. Yeah.
No, I agree, Russ. Thanks for the demonstration. Appreciate that. I think the only modification that I see that may have to happen there is that rack arm may not be able to come out just due to headroom. I think we're going to hit the bottom side of the buoy, but I don't see that obviously as a major issue. But that may be the only thing we need to consider is just the sequencing of that rack arm. It may need to go on the Nautilus tool before it actually gets put onto the ring.
Okay. Well, we have got different length of rack arms.
Okay.
We'll bring spares, and if necessary, we can just cut them down to suit.
Yeah.
I think also, just to clarify, we're going to do individual diver videos of each of the steps more clearly in advance of the mobilization, so that there'll be clear little diver instructor videos for each of the steps in the process Russ just went through there.
Yeah, no worries. And I've still got the old laminated one as well. I know it's just a general Nautilus lamination document. It's not showing it physically going onto the flange or a pipe, but it's just another guide which we can always give to the divers, which we normally do anyway.
Yeah,
but we'll get specific ones next week, Russ. We'll just get the exact details, so it makes it very clear.
Yep, no worries. So what's the next stage then, Esteban, that you'd like us to do?
Well, let me just see if there's anybody else have any other questions about, I mean, this is kind of the gear overview. Any questions from anybody about either the ACFM or the Nautilus/ring setup?
Esteban, I got a quick one for Dave on the MSF frame again. These quick.
Dave's just coming over.
Oh, sweat.
Somebody's got a question for you.
No problem. Hey guys, Dave Paramore here. Sorry, we're just setting up for later on.
No sweat. I got a quick one for you here. It's Mitchell with Suncor. The quick disconnects for once again, these adjustable slides for sizing to the eye tubes. Is there any concerns about slippage on those? Do they have some sort of like a rubber gasket that helps hold them in place?
Yes, they do. So it is something that you need to get used to. But basically, you can cam those down as tight as you want. But we're not finding an issue with those at all. Once sort of set up, they sort of just work straight away. And there's a little bit of stiction, I think you saw on the sort of brief demo that we gave you, and we can do it again, that it naturally wants to stay in the right place. So if your concern is sort of like moving away from the concentric position, we've done sort of several tests in preparation for today, and the bungee approach of pulling the scanner onto the eye tube works really well, and it's really nice and stable. So we hope we can give you a quick demo of that shortly when we're ready to do that part of the video demo.
Perfect. Yeah, and the only other thing I'd put out there, and this one's for you, Mike, with Technique, is just to have a think about whether you've got any concerns with any of those adjustment points with regards to divers and having diver gloves on, etc. I don't know.
Well, actually, we have considered ourselves that the adjustment for the probe slide, which adjusts the radial position of the probe, it's a little bit awkward. So we've already sort of from tests here, we've decided to give the diver a bit of help by manufacturing a 3D printed sort of knob that can be attached to the knob that's there, just to make that process a bit easier. So we're going to put him a bit of a bigger lever on, so with gloved hands he can adjust the tightness of the probe slide.
Great thinking, Dave.
Okay.
Sounds excellent.
Okay. If that's it, I'll hand you back over to Russ.
Yep. Thanks, Dave.
Okay, well, if there's no more questions, well, I guess what we can do is move ahead to installing the ring and the Nautilus on the flange, and start doing some of the scanning. So Russ, if you're there, maybe you can start demonstrating that portion of it. Is it at all possible to get the camera a bit closer, or is that not possible?
That's what I was going to suggest. We'll move the table closer. And what I'll do is, if you want, while me and Jamie, we're acting as divers, if you want to sort of talk through what we're actually doing, otherwise I'll have to move back and two from what we're doing to speaking to the call.
Sure,
So
no problem.
You're on keyboards and we're the divers.
Yeah, no problem. So I can narrate it, yeah.
All right, give us a second while we move everything a bit closer and get the camera set up properly.
Okay.
Drop us out. 2, 3. All right, we're a bit closer, but we may have to see where the camera's looking. That's not too bad, actually.
It's looking at the flange. I don't know if it's possible to get it a bit higher or not, but yeah, something like that I think will give a good view if that's possible. Yeah.
All right.
What's going on there? You can actually unplug the power on that, I think.
You've got the other 6 mil.
Should still run. Just watch that video back on.
All right, Ez. What we'll do is start off, we'll get the ring and we'll attach the ring.
Okay.
I guess maybe for those that aren't necessarily familiar, what you're looking at there would be a representation of the eye tube. Basically the 3 rings that you see at the top of your screen, that would represent the API flange. And then there are bolts that go down and actually connect. And so that piece that is in the water right now represents an elbow. It was manufactured through the same process that or as closely to possible as the same, the elbows that are underneath the eye tube. So out of duplex, it's a hot isostatically pressed forging. So basically it's as close to reality as what you'll see. If you notice the flange, it's connected to the elbow. That actually somehow manages to represent what the stud stick up would look like. So it's actually pretty close to the studs that would stick up off the API flange. So it's a decent representation of both the interfaces and the actual pieces that'll be out there in the water.
Yeah, thanks, Daniel. And yeah, obviously it's also upside down, just for those that haven't been looking at all the drawings like we have. So in the real world, this would be flipped, obviously. Yeah. All right. Okay, Russ, over to you.
Okay.
You can
Just
start when you're ready.
Bigger. Teeth up. So as I said, if you imagine we've opened and closed the ring, obviously it's quite loose. But again, as I said earlier, I'll start tightening one of the feet on one side. diver number 2 does the opposite, so we can get it just nipped up. We'll just move around to the next adjustable foot. Do exactly the same. You can hit level with the end of the flange, so we know we're perpendicular to the weld.
What kind of weight is the ring?
What kind of weight is the ring?
3-4 pounds. It's not very heavy. It's just aluminium. Right, nice and tight these now, mate. Not worried about the gap. It's protected.
Is the orientation of the ring critical, or can it be put on either way?
The orientation will be important. So we, the direction,
just to bring it in a bit.
probably install it the way it's shown with the gear, the what do you call it? The track or the gears will go towards the, you know, in the offshore it'll be facing down.
Yeah.
Level.
Okay, understood. Thanks.
All right. Okay, so that's the ring in situ. And again, one diver then will go and grab the Nautilus. Got it. And you can set the Nautilus up in any location circumferentially. So again, it's just, it slides on. One diver will hold it. Second diver will adjust the 3 bolts on each bearing. That's now the Nautilus locked on, and it's engaged with, again, that knurled cog. And the diver pretty much as tight as he can get it, then backs it off 1 full turn. And that's in situ now, that's secured. That won't go anywhere unless the operator topside physically drives it. Then again, the next part will be the rack arm, which we'll put on. Again, it's just, the diver just makes sure that this mechanism is out the way, and it's just a matter of, you can push that up. And then again, locks into position. That's in position now. The next stage would be, because we're doing the ACFM first for this, to bring the ACFM probe, 180 inboard. Underneath. That's it. I know you can't see this because of the tank, but it's just a matter of, the diver slides it on, tightens the aluminium knob on there, and that's in position. That's everything secured. From that point now, the Sonomatic technician on keyboards would take guidance from the ACFM guys of where they would like the transducer. Obviously 12 o'clock, wherever we have a datum, would they like it on the weld, above the toe, on the pipe, or below the weld? That's entirely up to where these guys want to start now. Which,
Okay.
what I'll do, I'll physically move the probe myself. If we don't want to drive, or we may get the diver to move this arm for us, you can just quickly disengage and then move the probe manually if necessary, but we can always do it through the machine. So it's like now I've set that probe, so it's just on the pipe, just above the top toe. But obviously it's not at the 12 o'clock datum. So what the guys had used, I would then get the divers and using their cameras, hat cameras, to tell me which way to go to get me to the datum point, so we can get everything datumed and everything checked, which I'll physically do now.
Russ, if we can just stop there and just, we'll just maybe open the floor to questions. So yeah, this is, at this point, the divers are pretty much just going to be video recorders. They're just showing us, just providing visuals. So that's the process for getting the ring on and getting in place. Any questions from anybody at this point? Okay, yep, it's a pretty straightforward process. So the scanner's a fully automated XY scanner. So once the Nautilus is on the ring and the correct scanner head is on the ring, then the Sonomatic team and the TSC team goes from there. We got full control of the scanner. So maybe Russ, if you guys can just show driving the scanner to the correct datum position, and then let's pull a scan.
Yeah, no problem. What I'm going to do now, I'm actually at datum there, Ez.
Okay.
I'll move it away from datum one direction. And I'll send it back to datum. That's now back at the datum point. I'm just going to check with the ACFM guys if they're happy at the actual axial position of the transducer, because I've got it just sat above the well toe. So
can you drive the arm in and out just to show how that works?
Yeah, I'll just do it a little bit, so because I don't want to clatter it.
Yeah.
That's going up.
Yep.
And then I'll send it back to 0. That's it. Great. Now gone back down to just sat above the toe.
Great, great.
Distorted, but the guys are just going to have a quick check now.
Okay. And while we're doing that, I will just tell the group, David did mention it. So we have identified that the probe needs more gimbling. So on one of the scans, we don't have enough movement in the probe head on either the intrados or the extrados. So that's something that to me, that's part of the purpose of doing these trials, to identify issues like that. So we have recorded it. We are already in the process of redesigning the scan ahead so that we'll have that gimbling, but that is an action that we'll need to sort out for next week.
Well above the toe there. Please notify on the toe if we can.
I think the other point to note now is once we've got the tool deployed, the diver's role here is to confirm locations, confirm orientation, and also cable management, just to advise us as the scanner moves that there's no chance of anything fouling or catching. So it's a sort of confirmation of location, cable management, general safety, and give us advice on where we are.
Yeah, okay. Now, happy with that?
One thing I just want to say regarding the Nautilus scanner, when it comes down, the actual this is a topside umbilical. The actual subsea umbilical is quite a bit thicker, and there's a hook on our scanner. We'll strung back our cable and put a Chinese finger on, which will hook through that hook for any movement back into the basket. So if the diver does accidentally drop it, all the weight will be at this point and not on this connector. But when we get it on like this, the diver will just unclip that with a carabiner, and that can just float. And as Gordy just mentioned, with the cable management, We'll make sure cabling's out of the way, etc., etc. But we'll probably have to do all the cable management by hand for this at the moment. I'll put the cable down so I can do the scan for the guys. You ready for me to do a scan?
Yeah.
Okay. There's enough in there. Just watch our cable. Right, the guys are just setting their machine up. Once they're happy, I'll pull a scan for them. I don't know if you guys want to talk amongst yourselves.
Might be Esteban, have you mentioned that we have some videos already of the system dry so that the divers can get an idea of the movement of the probes, etc.?
Yeah, well, the videos that I have are of the Toft head, so I was planning on showing that when we get to the Toft portion. David has recorded some videos that he's going to show around the ACFM.
Okay. The only other minor point is just make sure Russ doesn't try and claim his day rate as a diver for this.
Plus bonus, mate. Plus bonus.
I knew he'd hear that one. I knew he'd hear it.
Remember the welding divers when everything went good? They got a big bonus.
You write down the pen.
You let me know when you want me to go.
Yeah, okay. So we want to position the probe now at a different location. So we want you to move
Clockwise?
Anti-clockwise from the top. This way.
Well, that's going to be clockwise.
So you call that clockwise, do you? Yeah, no problem. So can we move clockwise, please? I'll tell you when to stop. Three, two, one, stop. It's perfect. Okay. And then when we do the scan, we're going to scan in the opposite direction. So I want to scan 360 degrees, like so. I just need a bit of help
We'll manage that.
We'll manage the cables.
But in the field, we're going to have to all use the same datum.
Yeah, we're using the same datum, just scanning in the opposite direction.
No, my datum's on there. And it's not our datum. This is manufacturer's datum. This point.
I understand. We're recording that datum. We're just starting ahead of the datum, so that
so you want me
the
to
probe
go
is actually in movement and tracking and stable before we hit the datum, and then we continue to go round.
Right.
Okay.
Give me 1 second then.
So before 1, we go over 1, then 12, then 11.
Right, what I'll do for you, start you there. Then you shoot that.
It's just the cardinal positions. Yep.
Dave, what I'm going to do then, I'm going to start there. I'm going to do a full 360, but then finish at the 12 o'clock, so you'll get a bit more.
Okay.
So we're at...
Okay. What about the speed? Can we adjust the speed?
Whatever you want.
So,
you want it faster, slower?
I want it 3/4 of what you moved that way.
Slower.
A bit slower, yeah.
All right, no worries.
Just because it's the first scan that we've done.
No, that's fine.
It'll give us time to say stop.
0, so that was 100 mil.
Who's
off.
on the cable? So,
You let me
stand
know.
by.
Just about to start a scan, guys.
Start scanning. Yeah, Mark. Mark.
I'm going to take that a bit closer. Oh, you looking
Mark.
at the counts?
Mark. 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 That's 3 o'clock. Mark.
1300.
Mark. Mark. That's 12 o'clock and stop.
Down. Okay. Yeah, oh no, I'll take the turn out.
Okay, so that would be, you know, 1 toe scan, and with the ACFM we need to do 3 scans. David, can you just explain what you were doing there, calling out the marks?
Yeah, so as far as we understand it, the diver is going to mark up the eye tube with clock positions. So 12 o'clock is up to the datum. 12 o'clock is the datum, and then we were scanning and calling out the marks. And what we do is we actually manually enter in the clock marks into the data. So superimposed on top of the data is the clock positions. So this is really useful for if you find any indications, you can immediately say from the data screen that those indications were between, say, 3 and 4 o'clock. And so you can go back and sort of investigate, take some more data if you need to. So it's just a visual reference to what is on the eye tube. So when you're looking at the data, it all makes sense. You know the position. Okay, so we're just winding the probe back now so that we don't get a twist of the cable.
And Esteban, can you confirm we've also got the encoder on there as well? Is that correct with the Nautilus system?
Yeah, the Nautilus is fully encoded. Yeah, so there's also going to be the ability, I assume, in the field we'll start, you know, knowing the millimeter positions for each clock position. So that's another way we can know where we are.
Yeah, 1 clock position on the pipe is 95 millimeters. Before I do anything, Dave.
And that 95, is that for one specific flame size?
Want to check?
That's correct. Yeah. So yeah, every flange size will have a different reading. Yeah.
But we'll know what those base values are, correct?
Absolutely. Yeah, that's part of the calibration process. When we first put the Nautilus on, is they'll calibrate the circumference. They'll run it a full circumference and work that out.
And that's done on every eye tube individually.
Yeah.
Yes. Yes.
Thanks, Esteban.
We want to actually.
And just to clarify, Mitch, on the ultrasonics, when we're doing TOFT and phased array, we actually use the encoders, so we don't need the diver to give us that confirmation. With the phased array and the UT, we actually use the encoders directly and can measure to the millimeter.
Well, I'm going to do a full scan.
Understood. But they won't be used for the ACFM portion? The encoder itself?
It's not directly hooked in, but yes, because of the linearity of this. Generally, TSC don't need that level of accuracy.
Right.
The benefit of this approach is we've
That's
got
just
that
driving
steady,
from-
constant speed, so it's almost an encoded feedback for the
Everyone
ACFM.
back at 12, please, James.
Understood.
I'm just checking something out at a minute, guys. Just give me 5 minutes.
And stop. Cable tight.
Sorry?
Stop.
Shouldn't be. It should be hung down there. Just want to come back to 12. Just want to check something.
Guys, question for Technique, I guess. Just a question around the video coverage of the probe doing the scan. I guess there'll be diver helmet cams, but
All right.
is it possible, or is it in the plan now to get a full, video of the scan going around, and so that video then can be matched up with the scan data?
So what did I say I need to move it?
So you're talking during the scanning, Jeff, or prior?
Yeah,
So, I guess,
for some reason,
well, certainly
yeah,
prior, but I was just wondering about during the scan as well.
Yeah, so certainly prior, yeah, there is a plan to complete full video recording of 360 degrees of every hotspot inspection area. During the scanning, we will have diver hat cam video, but I think from our perspective, they're going to be fairly busy managing the cables as the probe's going around. So I mean, that's something that we can certainly look at trying to do. But it'll be dependent on obviously their other priorities at the time.
Where you started. A bit further.
Okay.
Yeah,
I was just trying to see how, like, what Dave was calling out there with as the probe was passing the different clock positions, how that would be done by divers, I guess, and without somebody looking at it or at least a video on it, then that piece is not possible.
I'll move it for you.
Extracting the photo there.
Yeah, so I guess from our perspective, they'll do their best to call that out. But from what I understand, the fact that we have sort of this relative speed, you'll know where the probe is on the iTube even without that.
You go up, right?
Right. And another question is communication between the TSC operator, interpreters, and the communication path to the divers. So if there's any gap in information, or an area was missed because it's liftoff, or say is probably more relevant for Sonomatics tools, but liftoff due to some anomaly on the surface, that communication, is there somewhat of a direct communication between TSC, Sonomatic, and I guess the dive supervisor and then the diver?
Yeah, so my understanding right now is they'll have direct communication with the dive supervisor and the diver. So there are some spare headsets, I think, in dive control. So they'll be able to be tied in directly to that operation.
Okay.
Yeah, if I can add to that, so to the point of calling out the marks, once we calibrate the Nautilus on each flange, we'll know the millimeter distance for each clock position. So we don't necessarily need to rely on the diver to call out the clock positions as the scanner's traveling. The Sonomatic technician can call them out to the TSC tech, and they'll be sitting right next to each other. He can call them out when we hit a certain millimeter position. Let's say it's every 100 mil. He just says, yep, 100 mil, 1 o'clock, 2 o'clock. So we don't necessarily have to rely on the diver to call out the clock positions. The other point, I'll let David speak more to this because I don't know 100% on the ACFM portion of it, but at least in terms of TOFT and phased array, if there's probe liftoff, if there's areas where we're losing contact, we will know in real time because we'll see it in the data. So we're not relying on the diver to tell us that.
Right. Okay.
Yeah, the only thing I'll add into that too, as well, Mike, and you probably recall it, but during the harbor, I think we noted the importance of the divers maintaining a safe distance when this thing starts up, both from a rotating equipment concern as well as an energized equipment concern. So, the method you just mentioned, Esteban, about the Sonomatic text calling out the clock positions to TSC, that I think that would be the preferred method, just based on the safety of the harbor.
Absolutely.
Yeah, exactly. That's it's really going to be a priority is going to be on cable management and umbilical management, just to prevent anything like you're saying, Mitch.
The other point, just on the safety element, that I'd like to highlight as well is that the scanner has a stall feature. So if let's say a hand or a glove does happen to get caught in underneath the Nautilus, it will stall before it's not going to rip someone's finger off. It may cause a bit of pain, but it's not going to cause a huge injury. And also there is an emergency shutoff switch that is right where the Sonomatic technician is, so he can immediately cut power to everything if we do end up in a situation.
Okay. I guess the only other point I have to add now is just around the quickest piece of this whole of any of the inspection scope is actually doing the scans. So I guess just stressing the importance of making sure we've got the data before we move off the iTube, you know, and want to just understand how much validation is required from either the TSC or the Sonomatic operators to ensure they've got the right level of information, or as much information as we're looking for before we move off the iTube onto another one?
Absolutely. So we've had a lot of discussions around this. So all the technicians that will be on this project are, certified level 2 lead techs in their techniques, and we will. It's their responsibility as part of the process to ensure that there's a scan that doesn't require any follow-up before we move to the next iTube. So that is absolutely part of the procedure. The scans are all in real time, and the guys can quickly do a pass through them. When I say quickly, I mean within 15, 20 minutes to ensure that there's no major things that need to be followed up. So we don't intend to have to come back to do. The team is fully aware that we need to complete a thorough inspection of each well before we move on to the next one.
Yeah. Okay. Perfect. Thanks.
Yeah,
go ahead.
From a procedural aspect, Mike, you can confirm we've got that in there as an ITP point as well, just to make sure all parties are aligned and ready to move on.
Yeah, no, that's right. And I guess, Jeff, that'll come up as part of the session that we're going to have on Tuesday, just in terms of data and reporting sequence and requirements.
Okay, thanks.
Am I on mute? I'm ready. I just need to ask these guys a quick question. Can I ask the guys a question? When we're on site, it's just one to throw out there so it's less downtime for us changing scanners and setups. Just one for you guys to think about. Could we do all, it's like, I'm calling this one a 14.3 inch pipe because that's the OD. Would it be possible to do all of those locations first? Instead of bouncing across to different radius pipes, it just means it's less changing. Once we've got a setup for this, if we could then say there's 4 locations with this size, we go do those 4, then set up for another one and a smaller size and so on. Or will we be probably going from, let's say, a 14 inch down to a 9 inch back to a 14? It's just a question to discuss, because it gives us an idea as technicians then the kind of time we have in between locations to reset up the scanner for the different diameters.
Yeah, so that question's it's a little more involved. I agree with you. That certainly does make sense. But there are a number of other factors that play into that in terms of the coating removal and the recoating of the eye tubes. So I know with the recent sequence change that we've seen in the offshore schedule, I think we'll be reassessing that again, but that is something that we can certainly take into account when we finalize the sequence.
Yeah, no, I appreciate that, because I don't want to get into a situation when you're actually ready for us to do another location, but we've not redone all our equipment to be ready and available, if you know what I mean.
Yeah, no, absolutely understood. And I imagine we'll share the offshore schedule with you so that you guys can be prepared and you know what to expect when we're out in the field.
Lovely.
Yeah, that should hopefully streamline that.
Okay, lovely, appreciate that. But I'm just about to do the second scan with the ACFM guys. Again, it's just going to be the scanner. I've actually moved the probe now for them through the Nautilus. I've moved it 55 millimeters lower down, so the transducer is now sat on the weld cap. As I said, the diver doesn't need to do that. Once it's on, I can control it all from topside to wherever we need to be. So we're in position now. I'll just chat with the ACFM technician. He'll let me know when he wants to start, and I'll start the second scan for the guys.
Okay, stand by.
Hang on, there with me.
Marks.
Half the speed, and I'll just go to 1300. You tell me when.
Okay, stand by.
Yep, I'm ready.
Scanning.
Go.
Mark. Mark.
See that?
Mark. 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 Right. Mark. Mark. Mark.
8, 11, 13.
Mark. Mark. And stop.
Yep.
Can we have the final numbers?
Yeah.
Right, we just want to check that data if we could. So we're just going to review, check we've got everything in
But
line.
again, what I would do now in offshore, the guys will go, while the guys are checking their data, I will take the turn out of the cabling, and then I'll sit there and wait until they're happy with the data. Then I'll tell the diver, okay, we're happy, take this transducer off, and then we'd get the next, whatever, whether it's time of flight or phased array, transducer set up.
All right, thanks. Any question, guys? Further discussions on the acquisition of the ACFM data? All right. Well, at this point, I'm going to hand it over to David. He's going to talk through the data, I think, and then I think he wanted to quickly do a couple demonstrations around his MSF tool. So once they're ready, Russ, if you just want to hand it over to David.
Yeah. David?
Yeah.
I think it's on you about your data and something else. I'll let you talk to Esteban. while I'm taking this out.
Well, David, I wanted to hand it over to you. I don't know if you at this point we're gonna go over to the MSF tool. I don't know if you want to say anything else further about the acquisition of the ACFM.
The acquisition was pretty good, we think. We're just checking it because this is the first time, this is the second scan now that we've done with the Nautilus setup. We weren't able to do any scans with this yesterday, so we're just going to double check that everything's okay before we dismantle, so that we've got confirmed good data. So just give us a moment just to check the quality of the data. It looks very good, but I want to actually zoom in and just check we've got everything, because that's just 2 scans we've taken with the Nautilus system. So bear with us one moment.
Sure.
Circumference of the pipe, 1130. The clock positions are around, I think it's 94.6 millimeters.
Yeah, so guys, we just reviewed the data. Data looks very, very good. So we took a little bit of data yesterday by hand, and the data from the Nautilus scanner is sort of like 30% better. The noise is reduced, and the quality of the data, I would say, is perfect. The reason being, it's a really nice controlled scan using the Nautilus, constant scanning speed, constant force applying the probe to the surface, and you haven't got the diver, or the operator in our case, sort of trying to find his feet as he goes around the sample whilst keeping his eye on the probes. So it's much better quality data. We should be doing one more scan to complete full coverage of the well, so I suggest we do that, but we recognise that actually during this next scan, this is where we get a bit of lift off on 1 or 2 ends of the probe due to not having a gimbal. But we're still going to do the scan and see how we get on. So did we wind back to the start?
Yeah, just bear with me. Tell me where you want, how far down you want the probe.
Yeah, same start as last time.
So it was 50 mil, wasn't it? Just bear with me.
Something like another 20 mil down. That's it.
Is now joining.
Okay, so that's partly on the well, partly on the pad. I'm going to take a photo, so we've got it. No. Oh, you're happy with that? Happy with that. So we're covering 20 mil of the
No, I understand.
zone. So we now need to move
100 mil back.
signal back. Okay. Foot further, please.
All right. Okay, you let me know where you want to scan.
Are we ready? Stand by. Start scanning.
Moving.
Mark. 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 And stop.
Take the turn out. Back to 12. Yeah. But doing the reel in the field, you said you wanted to run up to 12. What I would do in the field, start at 12 and I'll overpass it on the back end. So you're still getting your 100 mil extra, you know what I mean?
Yeah, I think we wanted the datum quite close to the start so we can remove any errors relative
Yeah,
to the
but what I'm
datum.
saying,
So
I'll
we get
go.
the datum at the start and then the datum again at the end.
Oh, okay.
And then
Hey, Russ.
Hello.
While they go over the data, why don't we swap over to the Toft head, if you're ready for that?
Yeah, can do.
And maybe we can just pull the Toft scans.
Yeah.
yeah, guys, I think we're happy with the data. So that's the first run, and the data is good quality from the first 3 runs, so we're happy.
Okay, David, at this point, did you want to spend a bit of time on the MSF tool? And then we can come back and pull the TOF scans?
I'll be 2 minutes, Ed.
Okay.
Yeah, okay, if you're going to be just 2 minutes, let's get that done. And then we'll move on to the MSF.
So I'm gonna quickly share my screen, guys. We pulled a couple of videos yesterday with the TOF. So I'll just share my screen, and so you guys obviously won't be able to see what's going on in the tank, but I'll just show you what it looks like. So can everyone see my screen there?
Yep.
Okay. So this is essentially what's happening in the water. So we have a TOF head with 2 probes. It's a pitch catch technique. We need to do 3, just like the ACFM, we need to do 3 separate scans. We need to do a scan with the probe in the center of the weld, and then we need to do 2 offset scans. So we're covering the full weld volume, and we're also covering the heat effect zone on the other side of the weld. Fairly straightforward. So it'll just travel circumferentially around in 1 scan, and similar kinds of scan speeds as the ACFM. As you guys saw, doing a circumferential scan is going to take probably 30 seconds. So as was mentioned previously on the call, the actual physical scan time is really not that long. It's more setting up and moving. So also wanted to show you quickly what it looks like to the operator. So as a scan's being pulled in real time, this is what the operator's seeing on his screen, and the data is collected real time. So when we say that the operator can make real-time decisions on data, the guys will be able to open this scan up and assess it. With the TOF, at least, it's a fairly quick process to assess the data, to determine if you have to do any more scans, if there's any defects that you're concerned about. That's a fairly quick process. The phase array is a little bit more in depth because you're sweeping through a range of angles, so you have to kind of look at it. You don't see everything all at once the way you do with TOF. So that's a bit of an overview there on the TOF. So I'll let the guys finish getting set up, and then we'll just pull a couple of scans.
Signals look good.
The PAUT, like the initial interpretation, and as you mentioned, having to go through like angles. What does the time frame for that look like? Is it still done almost instantaneously? Just requires a bit more time.
So the phase array data is real time, just like the TOF data. It comes through in real time, but to look at it properly, I don't know, Gideon, what would your estimate be to look through a phase array scan without doing any detailed analysis and determine that's good for, that's good, we can move on or not?
I think it depends if you see anything significant. Obviously, if you see something significant or a crack or something, then you might want to look at it in more detail. But I think just to determine whether it's good enough to go to the next scan would probably be 5 minutes.
Okay. Understood. Thanks.
Look at that scan. Let's go. Yep. Okay, guys. So all we've done when we showed you earlier was a quick release. Take the ACFM probe off, take it out of the way, back into the basket for the guys. Then we have just brought this probe in, the time of flight probe, quick setup. Again, the diver with his hat cam, etc., would guide us to our datum points, all the same, etc., etc. And then it'll just be the same. We'd perform a minimum of 3 scans. Again, center line, offset upstream, offset downstream. If we did see anything, we may do a couple of extra scans. What we would also do is 1 scan as close to the heat affected zone on the pipe and the bend, just to confirm that there's no kind of corrosion in there that could affect the phased array inspection when we come to that. So theoretically, it would be performing exactly what we've just done with time of flight, but we'll be doing 5 scans, which I'm going to edit the procedure because the procedure states 3, but because we're hoping that there's no corrosion on your internal, but we may need to find out. So for the sake of an extra 10-15 minutes, we're thinking of adding into the procedure 2 parent material scans, just so we know that the internal surface is good as well. Yeah. Right, Jamie, leave the cables in the water, mate. I don't want to run over them. Okay. It's reversing. So again, we're all set up. I'll ask the diver, is he ready? And then it's a quick, simple, and we're away. So again, that's how long it takes with the time of flight to do 1 circumferential scan, less than 1 minute. We would obviously save it. We would then have a quick review of it, which would probably take another minute. And then we'd go for the next scan, next scan, next scan. So all going well, to do the time of flight, and I'm touching my head, touching wood, is probably 10 minutes to scan it, assess it, and go, yeah, we're happy with that. And then it'd be take this transducer off, store it away, get the phased array probe out, and then just carry on the same process with the phased array probes until we've totally completed the inspection.
Yeah, thanks for that, Russ. Yeah, unfortunately, the phased array wasn't, the probes weren't marinized in time for this demo, but the phased array is more or less the same process. The only difference with phased array is that it's not a pitch catch technique, so we need to scan the weld from both sides. So it's twice as many scans as we are doing with the Toft. So we'll have to scan from the one side and then swap the probe around and scan from the other side. The process will be essentially the same for swapping that probe around. It'll just be changing the orientation of it on the rack arm. So just the diver will loosen off that nut on the top, swap the probe around, and we scan it from the other side. So that more or less covers the UT portion of it. We will record, the intention next week is to record the phased array exactly as we've done here. And as Gordon mentioned, we'll be issuing short videos covering each portion. Any questions from anybody about anything that we've covered to date? till now. Okay, well, if there's no questions, Russ, is David ready with his MSF tool, if he wants to do anything there?
I will just about to grab him now. I'll just go and ask him. That's us done with that now. They're just asking, are you ready to
we're
go
ready
for that?
to.
While you're doing that, we'll de-rig.
Yeah.
There you go, Russ.
So Russ, I think if we can hand it over to Dave, and then once we're finished with Dave's portion, we can come back and just de-rig everything. Just show the exact same process again in reverse.
Yeah.
And then we'll be done from the top.
Roger.
Thank you.
Okay, I'm just going to check you guys can hear me.
All good, Dave. Thanks.
All good. So Matt's got the manual scanning frame. It's set up with the 542 probe attached. The cables are managed within the frame. He's now going to position the frame on our mock-up of the dissimilar metal weld. So the bungee strap sort of ensures that the unit is captive to the eye tube, and it pulls itself in. If you can just lift the MSF up a little bit so you can see the amount of force needed to pick it up off the surface. So we can see here we've got a gap underneath the magnets of around about 10 millimeters, and several wheels in contact with the surface. Could we have the other bungee on as well, please? So when we were scanning the radius on the forging, right, we found that because the probe needs to get sort of really close into that radius, there was a tendency for the MSF to wander by a couple of mil maybe, and we just thought we could improve that by increasing the force of the bungees. So our plan is to not have two bungees, but to have one bungee, but larger diameter bungee with greater force. So we're going to get the larger diameter bungee for the offshore part of the test. We'll have both available if we want to adjust. But the force that it's held onto the buoy surface seems about right. Now, can we turn the slightly over towards me, please? Okay. So can you show the adjustment of the probe relative to the radius? Okay, so we can choose any position. Obviously, the domed part of the forging is in the gap there. We don't have that present. So we're going to adjust the probe so that it's pretty much close to the edge of the metal that we've got on the model. And you'll notice that there are several screws as we go around that will give us a signal on one edge of the probe. And we've introduced a defect at around about 6 o'clock. Can we move around past the 6 o'clock? Okay, so point to the defect. So there's just a sort of like used a Dremel to put in a sample defect just quickly so that we've got some idea of sensitivity. Okay, now I can see that we haven't got the bungees set up right, so there's a gap between the, and it's not being held on by the bungees because the bungee direction is, yeah, it needs to be, I think, pulled. So you think it's right, do you? Okay. Yeah, okay. So we don't need to do a full 360-degree scan, I don't think. I've got one of those on video. What I'd like to do is scan between 7 and 4, say. Is that okay? Note that this time, instead of using the Sonomatic encoder, we're using the encoder that has a wheel sprung against the side of the plate. Just going to check. In my view, see the encoder's wheel isn't touching, so it's not like it has been. In my view, the force of the bungee is not in the right direction. So you need to set that in the right direction. Okay, so yeah. Okay, well we can try it, but
Okay. Ready? First mark 7, yeah.
So stand by on the ACFM.
Ready? Yeah. Scanning. Mark. 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 Mark.
And stop. Okay, so does data look okay? A little slower, okay.
Again?
Yep.
Ready? Scanning. Mark. 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 Mark.
And it'll stop. So data good? Okay, so we did this scan several times yesterday, in fact. We found we picked up the screw positions, we picked up the defect easily, and the function of the probe running around was pretty good. And the only problem we slightly have, which is these joins, and I can feel that the join doesn't quite line up here. So actually the probe sort of stumbles a bit when it gets to this this join, but it's not material to the job, and we successfully went over that yesterday. So now I'm going to show you a little bit of the AquaSign problem. We're going to do the same sort of scan, but we're going to have the AquaSign in place. I think we go over the same piece. So the AquaSign material is silicon rubber. It's a bit squashy, and it's 6 mil thick. So this clears the magnets, so the magnets go straight over the top. The problem is the wheels hit it, and you get a bit of uneven surface as you run over with the wheels. So if I position the that there, hold that in place.
Ready? Scanning. Mark. 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 Mark.
Yeah, so we've actually found that even without modification of the AquaSign, the scanner seems to run over it okay. We've taken a close-up of this, but you see that even when the wheels are running over the AquaSign, there's no essential movement of the probe relative to the surface. We've taken data, we've compared it with and without AquaSign being sort of encountered, and we find that there's no difference in the data. So I think this is something that we still need to get some experience with on site. Our preference is that if necessary, we'll take some of the edge off the AquaSign if it's strictly necessary. But we seem to be able to get away without it. 6 millimeters or probably 5 millimeters because there's a bit of a squash on the aqua sign. Doesn't affect the probe movement at all. So we think we're good there. We got the ramp. Ah, good. Can we try the ramp? Okay. So we just need to scan in the other direction, is that right? Yeah. So we go backwards over the same defect. Yeah. Put it there. Yeah. Where's the magnet? Yeah. You get move the right. Okay. Yeah. That's going to be okay, sir? Yeah. Yeah, that's okay. Yeah, that's what I want to say. 4, 3, 7. Ready? Scanning. Back. 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 So basically what we were showing there is that we can sort of magnetically attach a ramp that helps lead in the wheels to the aqua sign, and then it runs over. So it's a little bit smoother for the wheels to climb that ramp and go over the tool. So we're going to make more of these ramp devices, fix the magnet in place so it can be attached to the buoy surface, and we'll have to have ropes on them so they're captive and can't fall away and cause problems that way. So we'll take these for the job, but we don't think that we'll need to use them because we can run directly over the aqua sign with no ramp. Next thing, I think. Well, we're about to do some water tests next. Any questions on what we've done so far? You hear us? Yes.
Yeah, I'm hearing you guys, so I'm just assuming there's no questions. Yep.
Yeah, no problem. So, well,
I guess, Dave, one quick question now that I'm thinking about it. Have we done the test with the wheel removed for the R16 Clash?
No, we haven't done the test with the wheel removed yet. But okay. What we've discovered is that there's about a 10 millimeter clearance for us to reposition the wheel. So we think that issue goes away. So the offending wheel has, let's see if I can move it around. Patch there. Maybe a bit further. Okay, so it's a bit tight on this wheel, but you see there's a gap there of about 12 mil, and there's a locating point here. So sort of what we're going to do is drill additional holes in this part, move the wheel 10 millimeter closer to the scanner, and that should put us inside the Clash.
Yeah, excellent.
So I'm sorry we didn't spot that earlier. It's basically having everything set up properly with the mock-up enabled us to determine sort of like the clear way forward for that problem.
Yeah, no, I appreciate that. This is why we do the dimensional control checks, so it's a good solution.
Absolutely. Okay then, well, come back and ask more questions, but we're going to move on now to assessing the buoyancy of the MSF.
Are you going in the tank to do that?
We're just going to manually put it in the tank.
Okay. Well, what I'll do, while these guys are rearranging theirs, if possible, would it be beneficial for us to... Oh, they're just going to float it in. I was going to do our D-rig.
We're going to use the other one.
Use the other one, yeah.
Use the other one, because that's got the boxes on. Can we get any more cable on this, please, guys? Just a thing of the table legs got caught on the... So we need to lift the table. That's it. Don't need much. We still connected? Can you still hear me?
Yes, Dave, yes.
Yeah.
Thanks, guys. This way up? Yeah, that way I'd start off with. So, situation is we've got a buoyant device. We think we don't need the additional buoyancy. Can we turn it over, please? Okay, so as part of the test we did yesterday, we understood that we needed a little bit of buoyancy by the probe. So there's an extra block of buoyancy there just to support the probe weight. And when we had the model, the mock-up, if you like, installed the correct way up in the tank, we found that we could put this under the mock-up. It would suck itself up with a magnetic force very well. It attaches to the underside of the buoy surface. We found we could push the probe completely against its spring, such that the full spring force for the probe can be deployed and it doesn't break away from the buoy surface. And there's an additional approx 50 newtons to pull the frame away from the buoy surface. So not a huge force, not too much for the diver, but also easily adequate to do the ACFM inspection. We think that because we're in freshwater here, there'll be another 10% of buoyancy force on, and we think we won't need the additional pots. So can we turn over again and look at the pots? Can we remove those or remove the foam? Yeah. Yeah, so the foam is a bit of a tight fit in the pots. The pots can be used to sort of put a bit of air in, or you can put a bit of buoyancy foam in. We haven't locked it down yet, but there's that a bit of suction on the foam as well.
Dave, would you be able to move your camera a little bit to the right, please?
Sure.
Thank you.
Sorry, I can't see the picture at all.
No worries. You're good there now.
Sorry, guys. Didn't mean to make it a problem. Is it because it's in water, there's more suction?
So Dave, just to clarify, the thinking right now is that the MSF will likely go down with some sort of small weight attached to one of these pad or eye bolts, and then be removed.
We personally think it's about right. So it's slightly buoyant in fresh water, and we think it's going to be a little bit more buoyant in seawater. So we think we don't need the additional buoyancy from these pots.
Right.
So we're planning that's the way we start. You're right. We may need to add some weights to the eyelets. So, and turn over. Okay, so we may need to add some weights to the eyelets, but not very many. And I think it's difficult for us to determine exactly because of the salt water problem and the pressure problem. We're aware that the foam sort of tends to be compressed a little bit at depth. So as you go deeper, you get less buoyancy. So I think it's subtle from this point on. I don't think we can do much more at this stage to get it right. It's about right in our conclusion. So if you'd like us to invert the mock-up and put it in the tank so that you can see that, obviously that'll take a few minutes, but we can do that as well.
Yeah, I think if it can be done safely, there's benefit in showing the MSF in the actual in situ condition.
Yeah, roger that. So
hey, David, why don't we swap back? We can de-rig the Nautilus, give you some time to get that set up, and then we can come back.
Perfect. Thank you. Okay, guys, back to Nautilus.
So you just want to see us to do the de-rig, Ez?
Yeah, let's just do it in reverse. Take it off. Yep.
Yeah, all right, mate. So again, first thing we take off is the throne. Hang on, you've got a screen, which is just, again, quick release. We take that off, that'll get stored. Then I'll let Jamie go. The next one will be disengage the rack arm. And obviously, one diver holds the scanner, 4mm Allen key. U-turns on the 6. Got it? So that's a simple, that just lifts off, that gets stored away safely. Look, come underneath. And as I said, at this point, I'll just wait for Jamie to come back. We don't have to loosen all the feet. It's just a quick at the opening. just comes off, diver takes it, closes it, that gets stored away, and then once everything's secured in the basket they're getting manufactured, it's just a quick de-rig back to surface. And then prepare, obviously, we'll check everything, recheck everything, grease everything up, make sure nothing's broke, and get it ready for the next location. How's that for you, Ez?
That's great, man. Thank you for that.
No worries.
Yeah. Couple.
We're going to put these on this. We can start putting all that stuff out of the way. Probes for me. Put that in.
You like it?
Huh? Ah. Yeah, just let go.
Yeah.
Let go. Let them know that. Okay.
Okay.
Just want to let them know that you're.
Yeah, I understand what's going on. Okay. Okay. So. So, it's Dave back again. Hopefully you can see that the mock-up is now sort of inverted. So this is now the correct orientation compared with how we'll find the buoy offshore. We're just going to lift it into the tank. So bear with us.
Yeah. Yeah. Okay. Just need to get a.
Should be out there somewhere. Might be at the bottom of the tank.
No, we never used it.
I used it way down the tank.
No, one of the same. Yeah.
Yeah, I don't want to move the table too far away because we just want the camera, so if we can just swing it round. Thank you, Mark. Thank you. Perfect. We'll sort those if you like. They just need to be laid down the side, yeah, on the bottom. So, MSF going in. Okay, thank you. Thanks, Chris. Enough gap to get it in. So we have a sort of like a frame, a scaffold frame to support the sample at the right height. So it's a bit awkward getting it between the frame and the mock-up of the buoy. But you can see that actually it's already sort of on and scanning around the surface. If you just hold there a second. Can everybody see? It's through the water as well. But basically,
Yeah, we see that.
If I push down on the black MSF, I have to push by about 5 kilos, and you see I let go, and it sucks itself straight back up with the magnets. So it's pretty much aligned.
Dave, do you expect much difference in the magnet's attraction with a coated surface?
No, I think from what you mentioned, it was about 1 millimeter nominal coating. So we're at the maximum distance away from the surface with the magnets at the moment. So say you had a 3 millimeter coating, we could adjust the position of the magnets 3 millimeter closer to the surface, still miss the aquastine material, and still have a gap between the magnets and the inspection surface, and have the same pull force. So we've got lots of sort of capability to maneuver around. But I know it's only a sort of like an empirical assessment, because we haven't got a calibrated force to take the pull it down at the moment. But we do have a spring where the probe is. Right? Can we move around so we can see the probe at this end?
Yeah.
Yeah. So we can see it now, actually, through the gap. Leave it there. Okay. So yeah.
You can see it.
Okay. So the probe isn't particularly aligned to suit the. So it looks like it's potentially on the forging side of the weld at the moment, but you can just see the probe. Sorry?
Can they see it?
I think I can see, but I'm going to ask the question. So there's a bit of green tape on the probe. If we push that probe, push it down. Okay, and off. So that was to the bottom of the spring?
There onto the bottom.
You're there to the bottom, and there's a bit more.
Yeah.
So, okay, perhaps it's 30 newtons to remove the system, but we're pretty much there. I personally think actually we need a tad more buoyancy on the probe end.
Yeah,
just to trim that, so probably twice that amount of buoyancy. But I hope that illustrates that even with the awkwardness of not being able to see very well and sort of get it there, we can get the scanner into place quite quickly. It naturally wants to sit and be stable in the right place. So I think the divers should have a good chance of being able to use this tool quite well. I think yesterday when we started scanning with this, we found that we could pretty much scan, and we, apart from the joins between the plates, which perhaps we should have sorted out, but we weren't worried about, everything went really smoothly. So it's a good sign that things are set up about right. And we have potential for more adjustments offshore if we find any problems. Yeah, we think we're just about there.
And Dave, you made some commentary earlier regarding the improved quality of data using the Nautilus system for various reasons, at scan speed and stability of the probe. Are we seeing similar improvements with the MSF versus freehand scanning?
Absolutely. So we concluded sort of from here, compared with a normal diver job, where there's a lot of marking out to be done, a lot of, you can just imagine when you're actually doing the scanning ourselves, we can see that actually getting yourself into position and sort of maneuvering your body and having the reaction sort of force on your feet to move the probe, that makes scanning so awkward just as a diver. Whereas with this tool, it's up against the eye tube, it's in the right position. You've still got to keep an eye on it. So we need the hat camera from the diver to actually be in place, or additional sort of views so that we can definitely see the probe and its track to confirm correct coverage. But bottom line is it sort of fits into place naturally quite well. And with a bit of care, you're following exactly the same track. So if you remember, I was showing you the screws on the very edge of the C plates. They turned out to be a really useful sort of reference point because we see those screws with the same sort of signal each time we pass over a screw, and we put our defect in between two screws, and you can see the difference in signal from a defect to that from a screw, and it just everything sort of exuded quality because you can see exactly what's happening in the data with no problems. So we felt pretty good about it. It was definitely worth doing the wet test. We can see that a little bit of extra buoyancy is needed sort of by the probe, but we're not in a position where we're far off. We can't guarantee that the divers might not want it to be a little bit more heavy, or maybe possibly a bit lighter, but we've got options to do both of those, and we don't know which way to do it at this stage. So I think we're in very good shape to deliver success on the job. Okay.
All right. Thank you, David.
Yeah, I'll just confirm that actually we took some significant data yesterday on the sample that's currently in the tank, but on the forging radius, and also complete scans around the dissimilar metal weld mock-up that we've got. So we have those already videoed, and we can share those as part of the reporting. And you can see, I think, the quality of the scanning and the quality of the data is good. So I think we're in good shape. I would like to ask, though, we haven't seen any sign of the proper dissimilar metal weld test piece. Have we got an update on the location of that test piece?
I don't, Dave. If we're chasing that right now, we'll let you know once we hear something.
Yeah, okay.
We had some pre-clearance documentation arrive yesterday suggesting it was in Heathrow.
Okay.
Gotcha. Yeah, we're supposed to get out of there as quick as possible, so that's we chased it yesterday afternoon. We're chasing it this morning, so we're just waiting for an update from the shipping company.
Understood.
Okay. So could we have a formal update on that within the hour to us, and then we can make a decision whether to stay on and do a scan on the dissimilar metal weld, or just wait for it to arrive and ship it down to us next week.
Yeah, for sure. So like I said, right now we're just waiting for word back from the shipping company.
Yeah.
So once we get that, we'll let you know.
Okay. So is there anything else I can show you? Is there any sort of things that you want to catch up on?
Hey, Dave, one question. It's not necessarily something that would be a demonstration, but is there a 5-inch elbow over there as well?
Is there a what, sorry?
One of the smaller elbows over at Sonomatic as well?
Yes, I think there is. If you could just confirm with Jamie and Russ, Dave, but I'm pretty sure there is.
Yeah, Jamie's here.
Yep. Sorry, what's the question? Can't quite hear.
Is there one of the 5-inch elbows? Is there one of the smaller elbows there?
There is in the workshop, yes.
So, Dave, I don't know if it's worth doing, but have you just kind of fit test the MSF around there and done adjustments to make sure that it meets the OD of the 5-inch as well?
No, we haven't done that. I didn't realise that sample was here. So we can offer that up now.
Yeah, it's not necessarily something we have to do on video. It's just more for you guys just to verify that the adjustability works and that you do meet the smaller elbows. I think the other elbows would be in between the small size and the big size you have. So, if you can make it work for the 5-inch elbow, then it should work for all. Just maybe something you could do while you're there just to get a good feel for it, make sure there's no issues.
Yeah, for sure. So we'll go and eyeball that now, and we should be able to carry an MSF over there and sort of offer it up and check pretty quickly.
Okay, well, we're a bit ahead of schedule. That kind of covers what I was hoping to get out of this. I don't know, Daniel or Mitch or Dana, if there's anything else you guys want to discuss or see at this point.
No, that covers it for me for now, Esteban. Thanks. Just to know, for the sort of instructional video part of it, is that already done or happening next week?
Yeah, so we've recorded parts of it, but we'll have those issued. I think the plan is to try and get all those finalized by the end of next week and load it up to YouTube.
Yeah, because that's the part where you disassembled the Nautilus, and also the part previously where you were looking at having done the top scan in the dry. That was very useful.
Yeah, yeah, absolutely. We'll be posting all that. This is also being recorded, so I'm going to post this entire stream to, we'll distribute this. I'll also have a look to see if I can just edit out. Obviously, there's been a lot of, downtime. Maybe if I can edit this video. I've never recorded a Teams thing yet, so I'm going to see if I can edit it down to just the relevant portions and try and issue that as well.
Right on, thank you.
Okay, anything else from anyone else?
No, nothing further from my end, Esteban. I'd just like to thank yourself and your team, and same for Dave and his team with TSC. Fabulous job here. So exceeded expectations. I thought it was quite well, very well laid out. Did a great job. So appreciate your efforts.
Excellent. Thank you, Mitch. We really appreciate it. Same thing, guys, over in the UK, TSC, and also our Sonomatic team. You guys did a great job, so thank you. Given the circumstances, I think this went really well. Yeah, looking forward to the job. All right, guys. Well, if that's it, then we'll wrap it up. I'll send out this stream to everybody as soon as I have it available, and we'll catch up next week in the weekly meetings.
Thank you.
Thanks,
everybody.
Thanks, everybody.
Thanks, guys.
Cheers, thanks a lot. Bye.
Thank you.
Thank you. Bye.
Bye.
Is now exiting.